ये हमारा रेडार सिस्टम है, हमारा अल्ट्रासोनिक सेंसर है जो मोशन डिटेक्ट कर रहा है, और ये सर्वो मोटर पे लगा हुआ है जो ESP से कनेक्टेड है और फिर कोड रन हो रहा है। तो ये मूवमेंट होगी जैसे दूसरा।
Assalamu alaikum. I, Abdullah Zafar, along with Ismail Muhammad Riaz and Muhammad Huzaifa. We are from Bachelors of Science in Mechatronics Engineering semester first. This is our first project of ICT, which is basically building a radar system with Arduino. In this project, when someone passes and something or someone passes across the sensor, there is a it should produce a beam sound like a buzzer sound produces. So it uses ultrasonic waves for that, and unveiling the principles of radar technology through an accessible Arduino project. This is basically our project. Now move forward to the slides. Table of contents. Introduction. In basically in this project presentation, we have, first of all, we have introduction to Arduino radar, which is basically understanding the basic and applications. Next, we have key components explained, dividing into the hardware and its function. Uh, Next, we have setting up the hardware, step-by-step assembly guides. Arduino code fundamental, programming the brain of radar. After that, we have visualizing radar data, creating a user interface for object detection. Means, okay, application and future enhancement, exploring real world uses and potential improvements. Conclusion, summary, key learnings. Presenters meet the team behind the project. So move forward. Uh, this is basically our introduction to Arduino radar system. Radar, an acronym for radio detection and ranging. It's a detection system that uses radio waves to determine the range. It means that radar is using something radio waves to detect when someone passes or something passes across the sensor. It should produce a beam sound, the range, angle, or velocity of the object. While traditional radar systems are complex and costly, we can leverage the versatility of Arduino to build a simplified yet functional radar model. This project provides a hand-on understanding of how radar works. This is basically a project of first semester students in which we are not going so much complex things. We are doing the basic things for like learning how radar works in big companies, industries, and other areas where radar system are so big and complex. When someone enters the someone and something passes through the radar system and it produces alarm and all things. Basically, we are doing the simple things for all that just to learn how radar system works. Or key components: Arduino SC SR04 ultrasonic sensor, SG90 micro servo motor, breadboard, and jumper wire. Basically, Arduino do that for like we put codes in the Arduino, connecting with it with the Wi-Fi hotspot, whatever you want to connect it, where and whom you connect it. It's totally up to us. So we connected it with hotspot. After that, we put it into code and all the things just and all the data are uploaded on ThinkSpace, and we are checking on it. After that, we have ultrasonic sensor. Basically, the ultrasonic sensor are used for some like to detect something when someone passes or something is passing across the sensor, as I told you before. After that, we have SG90 micro servo motor. Instead, we have this. Instead, we are using buzzer or servo 90 motor. Means the same. When someone passes across the server, if we put a buzzer sound, a beam sensor, it should produce a beam sound. Otherwise, if we put a servo motor, the servo motor runs and rotate when someone passes across the sensor. We have breadboard and jumper wires to like for the temporary circuit. After that, we this is not a permanent circuit on breadboard. Breadboard is basically for temporary circuits. After that, we can uh, unassemble it. Setting up the hardware, a step-by-step guide. First, mount the motor server. Secure the SG90 motor server to stable base, ensuring it has a full range of motor. Ultrasonic sensor. Mount the SC sensor on the server horn. This allows the sensor to rotate and scan. Connect servo to Arduino. Orange wire signal to digital pin 9. Red wire VCC to 5 volt. Brown wire ground to ground. Connect ultrasonic sensor to Arduino, VCC to 5 volt ground to ground, trig pin to digital pin 10, eco pin to digital pin 10. Arduino code fundamentals, bringing it to life. The Arduino code orchestrates the entire radar system. It controls the servo motor sweeping motions, trigger the ultrasonic sensor, calculate distances, and send the data to a computer for visualization. Servo motor. Using the servo motor H library to control the servo angle, ultrasonic ranging, sending a short pulse from the trig pin and measuring the duration of the echo on the echo pin, distance calculation, converting the time of flight to distance using the speed of sound, serial communications, sending angle and distance data to a serial monitor or processing application, looping and delays, implementing a continuous scan with appropriate delays for accurate reading. Visualizing, visualizing radar data with processing IDI to interpret the data collected by the Arduino radar. We use the processing IDI to create a graphical user interface GUI. This GUI receives serial data, angle, and distance from the Arduino and plots it on 2D representation, simulating a classic radar screen. The sketch will processing sketch will be should be look like this. Establish serial communication. Connect the Arduino serial port to receive data. Draw a radar screen. Create a curricular display with sweeping lines and object indicators. Plot object based on the received angle and distance. Draw points on the radar screen to detect object. Update in real time. Continuously refresh the display as new data arrives from Arduino. Basically, this is all that we have the servo motor, breadboard, jumper wires, ultrasonic waves, or Arduino. Uh, Arduino runs the code to our ultrasonic radar sensor. When something is passing across the radar system, the radar system uh, basically convey the signals to servo motor or buzzer, whatever you want to put on a breadboard. Across after the servo motor, there is a buzzer sound, or so if we have a buzzer, then it produces a buzzer sound. Otherwise, the servo motor runs, rotates. So basically, an update in real time mean that when it Arduino like continuously fresh the display of new data wrap. Application and future enhancement. The Arduino radar system, while simple demonstration, fundamental principle with wide-ranging application and potential for enhancement. Current application and future enhancement. In current application, we have basic object proximity sensing, educational tool for STEM, simple security system, and much more. Like future enhancement, we can develop advanced object for tracking capabilities, connect to a web interference monitoring. Conclusion. Branding, theory, and practice. The Arduino based radar system project has a practical exploration into the core principle of radar technology. Means the Arduino has a wide range in a radar technology. Means Arduino, there's a more much sensor of ultrasonic wave in which there are so much other things instead of the radar thing. But we choose radar just to know how radar works in like big companies or no. By assembling hardware, coding, logging, we demonstrate how radar system basically work on a small scale. Obviously, when we upgrade it to a big scale or in industries, factories, or wherever the where the radar is moving or radar is using in a big ranges. The coding is going complex and complex. We hope this presentation inspire you to explore the fascinating world of sensor technology and embedding system. Presenters Muhammad Abdullah Zafar, Ismail Muhammad Riaz, Muhammad Huzaifa. Thank you for the attention.